Hey guys, welcome back. So in the last video, we discussed about identity operators, and in this video, we will talk about another very interesting operator, which is known as a membership operator. So membership operator, as the name suggests, like it is used to check if a particular item is contained in a particular sequence. The sequence can be a string, list, tuple, set, and so on. So let us dive in and check with examples. So let us say we have a two list L1, and let us say we have 2, 3, 4, and let us say we have another list L2, and let us say we have 1, 2, 5, 4, 7. Okay, let us add one more element, 9. So let us see that if we want to check what are the elements which are overlapping, it means the elements which are in both the lists. Okay, how we will do it in basics, like with basic code using for loop. So let us say we have for L1 item in L1, and let us say we have for L2 item in L2. So we will simply say if L1 item is equal to L2 item, then let us create a empty list here. Let us say all overlapped items. Okay, and let's simply append them. Append L1 item, and let's simply print it. Print overlapped. So let us run and see it. So what are the overlapping items are? It is 2, 4. Okay, and that's it, I guess. Let us run and see it. You see, 2 and 4 are the overlapping item. So what is the difference? Like simply we can implement it again using optimized as well as more readable way. So what we can do is simply we can say remove this loop and simply say if L1 item is L1 item in L2. That's it. So you see it is quite readable. So we are saying that for L1 item in L1, if L1 item is in L2 means list 2. So it's like simple. We are saying if this item in this list, and if it is true, then simply append it. So it will return true if it is in list, otherwise it will return false. Okay, and let us run and see it. So you see both of them same. It is not only just readable or very clear in code, it is also really fast. So let us see like how it is faster. So let us let us use same module that we have been using. So let us import time it, and let us say we have this is code basic, and simply copy this part inside code block. Okay, and let us do the same thing for this part as well, and let us name it code in. Okay, and then let us copy this code inside this, and let us run both code say 10,000 times. Let us say print time it dot time it, and let us say code basics, and then let us say numbers is equal to 10,000 times, and let us run the same thing for code in. Okay, so let us run and see it. So you see it is like compared to is equal to, it is quite fast, like it says 40 0.0040 seconds, whereas this said like 0.0064 seconds. If you want to see a bit more clear, we just simply increase the number of times. It will now simply change it to a bit much better. Like it says 0.069, 0.49. It's like around 70 versus 40. So okay. So also we can see like in our data structure video, we said that set and tuple are faster than list. So we can check that here as well. So if we can simply copy this code and let us say we simply change this to set. Let us start with tuple. Okay. So here, and let us say this code is tuple and simply change it here as well. Okay. So tuple is expected to be faster than um, list. Okay, but set is even faster. So we will see another. We will add that as well. Let us see with this. So no, it is not that much fast compared to list. They are kind of comparable. Which one I added? List and tuple. Okay, that's okay. Let us try. They are comparable. They are not like 0.04 difference. It's not much. So let us say set, so which is really optimized for this particular operator, which is membership operator. Okay, so for set it will be really fast compared to any other data structure. Okay, let us say code set and let us run it. What let us do is let us actually say that we have a bit bigger list. Let us say we have multiplied it 100 times so that it will show it a bit more clearly. Okay, so now the this list size is like around 500 items we are checking in. Okay, now let us see the difference. Now it will show a bit more differentiable size where we can see the difference. So you see it took 4.79 second, it took 1.2 second, 1.2 second, and this took 0.4 second. You see the big difference now. So this is like when we have a condition or when we have a situation where we need to check if a particular item in a sequence and that sequence is not going to be changed during the process. So simply, I mean, use set to do that process. It will be really quick. Okay. So let us see not in operator. So not in operator is simply like it is directly opposite to in operator. So let us say if we have simply a list lst1 is equal to 1 2 3 4, and if we want to check if, let us say we have item is equal to 4, and if we want to check if item not in lst print the item, we can simply add that as well. So we will use f string here to format. Not in the list, else we can say. Yeah, so you see it is directly opposite to in operator. Okay, so let us run and see it. Let's just comment out and leave it. Just print a new line here so that it will be a new line. Okay, so you see, for the item 4 is in the list. Let us say something which is not. Say 9, so now it will simply say the item is not in the list. Okay, so I think it should be clear like what are in and not in operators are membership operators. In the next video, we will talk about extension of and or operator, which is called as any and all operators. So subscribe to the channel if you haven't subscribed yet. And thanks for watching. Bye for now. Take care.